All right, welcome back. To start this next video, here are four warm-up questions. If you want to pause the video for a little bit and try to figure these out, go right ahead. If you happen to download the packet or ask me nicely for permission to download the packet, you could find these exercises or examples of them on pages 4 and 5 in that packet. But let me know if you want to download that. Just send me a quick message. All right, in this video, we're going to take a look at solving more types of linear equations, a little more complicated ones. Just as a reminder, when we solve algebraic equations, we're looking for inverse operations. And here's a list of all the operations and their relative inverses, and what we would do if you see something in a particular equation. When we have multi-step equations, we want to undo those operations by working backwards, which we call the inverse. So when you see an equation, you want to ask yourself, what's the first thing being done to the variable? In this case, x. Very often we use x, but not always. What's the second thing being done? And recall your order of operations as you answer these questions. So you want to ask yourself, what's the first thing being done to the x? What's the next thing being done? If you knew what x was, what would you do first, and what would you do second to that number x? Well, it's being divided by 2, and then we subtract 3 to get the result, or from that result. So, to undo that, since we don't know what x is, we want to do the inverse operations in the reverse order. We've got to work backwards. So one thing I suggest, especially when you're first starting out with these things, is to use what I call a see-do table. And here's where you can plan out your steps. So you will record down what you see in the equation, and then you'll write down the inverse of those operations to plan out what you should do. So I call this a see and do table. And especially at the beginning, when you're first starting this out, you need to make a plan. As you get better and better at these, you'll be less needing to write it down. You can probably do more of it in your head. So, like we said, in this equation, the first step is dividing by 2. The second step is subtracting 3. Going backwards, we're going to add 3 and multiply by 2. Okay? And we just follow out the steps in that do column to isolate our variable and figure out what it's equal to. Okay, we want to separate our left and right sides, and we're going to follow those steps. The first step is add 3 to both sides, simplify, of course, bring down, and do our next step. Here we have a divide by 2. We're going to multiply by 2, simplify, that clears that denominator of 2, and we have our result of x equals -8. Of course, we always want to check our answer to make sure that it works. Here's another one. Solve 2x minus 1 equals -3. We build a little see-do table in the corner of our paper, on the margin, wherever you might need to do it, just to plan out your steps. Notice that x is being multiplied by 2, and then we subtract 1. So we'll do the reverse, or inverse technically, add 1, and then divide by 2. Okay, now we'll just follow those steps. Add 1 to both sides, simplify, divide both sides by 2, simplify, and we get our answer. And of course, check. All right. Number 3, x divided by 3 minus 4 equals 8, or x over 3 as some people say, minus 4 equals 8. See-do table. Divide by 3 minus 4. So we're going to add 4 and then multiply by 3. Okay, let's just follow those steps. Add 4. Simplify and bring down. Multiply by 3. Simplify and bring down. We get our answer. If you had a 3-step problem, 4-step problem, same idea. You just have more steps. Always check your answer. All right. 3y minus 1 equals 8. I will not show you the steps to this one. If you want to pause for a second to figure out the answer. Hopefully you got A, y is equal to 3. You can always throw that back in there and check. 3 times 3 is 9, minus 1 is indeed equal to 8. Okay. A little different. D minus 4 is in the numerator, divided by 2. 2 is in the denominator. Again, if we make our see-do table, follow those steps. If you knew what D was, you'd minus 4 and then divide by 2. So we're going to go backwards, times 2, then plus 4. Okay. We want to multiply by 2 to clear that denominator first. Simplify and bring down. We've D minus 4 equals 6. Add 4 to both sides. Simplify and bring down. D is equal to 10. Check. Sure enough, 10 minus 4 is 6. 6 divided by 2 is indeed 3. Another multiple choice. Okay, pause if you need more time. Should get B. D is equal to negative 19. Negative 19 plus 1 is negative 18. Negative 18 divided by 3 is negative 6. Ooh, this one's a little trickier. Okay, notice that sign there in front of the terms, or the signs, I should say, in front of the terms. It looks a little different than the other ones. So you got to pay close attention to signs here. What's happening to that A? Well, what do you see? Well, if you think about it, technically it's being divided by negative 7. That is one way to look at it. There are other ways to look at it, but dividing by negative 7, putting that negative with the 7, might make it a little bit easier. And 3 is then being added to it. We could actually write it that way as A divided by negative 7 plus 3. Notice the 3 is a positive 3, which we could write as plus 3. But because it's in the first term, the leading term, we don't need to write the plus in front of it. But if it were anywhere else in the equation, we would write it as a plus 3. So because of that, our steps are subtract 3 and multiply by negative 7. Let's see if that works. Subtract 3 from both sides. Okay, that leaves the negative in front because that 3 does not clear that negative yet. That's why we need to multiply by negative 7. All right, once we do that, that clears the 7 and the negative from the left side. And on the right side, we end up with negative 5 times negative 7, which gives us a positive 35. And if we put back in to check, we see that indeed it does work. 35 divided by 7 does give us 5, or negative 5 if you want to look at it in one way. 3 minus 5 is negative 2. Okay. 5z plus 16 equals 51. Hopefully you got z is equal to 7. 5 times 7 is 35, plus 16 is 51. Okay, we have another one here. 3x over 5 plus 1 equals 4. Some people see that as 3/5. Some people see it as 3x divided by 5. Okay, so there's a couple different ways you can look at this. If you're pretty good with fractions, you can reduce this to a two-step problem, but let's keep it as a three-step problem. So x is multiplied by 3, then divided by 5, then plus 1. So this becomes a three-step problem in this case. Again, if you're good with fractions, this might be a two-step problem. We're going to subtract 1, multiply by 5, and divide by 3, the inverse operations in the reverse order. And let's carry those out. Subtract the 1 from both sides. Clear the denominator. Multiply by 5. Divide both parts by 3. X is equal to 5. And we can go back and check. 3 times 5 is 15. 15 divided by 5 is 3. 3 plus 1 is 4. All right, and if you did download the packet, there's some exercises on pages 6 and 7.